Okay, so finishing up number 2, you take your 8.452 seconds and you fill it in for your equation delta D for the motorcycle. So 1/2 4.4 times that 8.452 seconds squared, and you should get 157.14 meters. Then you do the same thing over here. You fill in for the car 1/2 3.7 meters per second, 8.452 seconds squared, and when you do that you should get 132.14 meters. Now you'll know you've done it right if the 1.32.14 meters, 132.14 meters, and the 157.14 meters are 25 meters apart, and they are, so you're good. That was part B. Part C says, how far ahead of the car will the motorcycle be 2 seconds later? So 2 seconds later is going to be 10.452 seconds, so you need to find the delta D of the motorcycle of that. So 1/2 4.4 meters per second squared by 10.452 seconds squared. And when you do that, you get a delta D of the motorcycle to be 240.32 meters. And that, again, depends on where you round it this time. And then do it for the car. Delta D of the car, 1/2 3.7 meters per second squared, 10.452 seconds squared. And you get a delta D of the car to be 202.08 meters. Okay, and the question wants to know how far ahead is the motorcycle than the car. So you would subtract your 240.32 meters. You would take away from that the 202, and so in part C, delta D is 240.32 meters minus 202.08 meters. And so you're going to get a delta D of 38.24 meters, or something around that, depending on where you rounded your time. Okay? All right, I hope all that is good for number 2. I also asked you to do number 3. And number 3's a little bit different again. Okay, so it says, a student throws a ball vertically upward with an initial speed of 9.81 meters per second. Another student standing 5 meters away starts running towards the ball on release and catches it at the same height. So the two parts are the ball being thrown up and the student who's running in. Okay, so first if we look at the ball, it tells us the VI is 9.81 meters per second, and that's up. We know A is 9.81 meters per second squared, and that's down. And we know it's going to go up until it stops. So the VF at the top will equal 0. And from that we can find the time that it takes to go up, delta TU. And then to double that, we would get the whole time. So if we go to the student before we do any of that, it says another student is standing 5 meters away. So delta D is 5 meters, and they're standing, which means VI is 0. And immediately starts running towards the ball on release and catches it at the same height. What is the student's acceleration? So if they begin to run in, right, so you have this ball going up and coming down, and you have the student running in at that instant. So the time the student has to catch the ball should be equal to twice the time it takes the ball to go up, or in other words, the full time of the ball. So if we look at it, and we don't know what that is, so we have two unknowns under the student. We only have one under the ball, so we can find it. So VIA, VF delta T, so A is equal to VF minus VI over delta T. So if we're looking at the time to go up, V time up will equal VF minus VI over A, but the VF will go to 0. So the time up will be negative 9.81 meters per second, and it goes in as a positive because it's up and that minus sign is from the equation. Gravity has to go in as a negative 9.81 meters per second squared. So the time up is going to be 1 second, which means the full time is 2 seconds. So now we can go to the student, and we want the A. We have the delta D, the VI, and the delta T. So delta D is equal to VI delta T, 1/2 A delta T squared. Okay, and the VI goes to 0. So delta D is equal to 1/2 A delta T squared. We're rearranging for A. So multiply both sides by 2, divide by T squared. So 2 times 5, it should be about 10, divided by 2 seconds squared. So 10 over 4, 2.5 meters per second squared. And here's hoping that that's the answer. Okay? So that's number 3 on the back. All right, so now where I'd like to go is to your example sheet, because we did not do example 7 and example 8. And they're with others with examples of throwing objects up or dropping them. Okay, so let's do these two. That way you're ready for anything. So number 7, you throw a ball upward and it passes by a window 3 meters above the ground. Okay, so the two sections are going to be below window and the window, because it passes by a window. The window is 2 meters tall. It takes 0.4 seconds to go by it. With what velocity did you throw it? So you're throwing it up with some VI, and we don't know what it is. And when it's throwing up like this, I tend to put my givens up and down because it's easier to connect them. We know A is 9.81 meters per second squared down, and the object's going up, so we know we're going to have to put some negatives in here. It passes by a window 3 meters above the ground, so delta D is 3 meters, and that's up. The window is 2 meters tall, so delta D of the window is 2 meters, still going up. A is still 9.81 meters per second squared down. It takes 0.4 seconds to go by the window, so that's the time up here. 0.4 seconds. With what initial velocity did you throw the ball? Okay, so before you can find that, you have to say what connects the two parts. So below the window and above the window. Just think about it for a second. What connects them? There's always something that connects them. And I would suggest you think about the VF of below the window and the VI of above the window. I'm hoping you can realize that those are going to be the same, right? Because the instant it gets to the window, that's the VF of below, and that's the VI of above. So we don't know what it is, but if we knew it, then we could find our VI at the bottom. So let's start at the window, because the only unknown we have is the VI. We have delta D, we have A, we have delta T, we want VI. So do delta D is equal to VI delta T, 1/2 A delta T squared, and you're rearranging for VI. So delta D minus 1/2 A delta T squared is equal to VI delta T, and then divide by the delta T. So delta D minus 1/2 A delta T squared over delta T. Okay, so now we fill in our numbers. Delta D is going up and it's 2 meters, minus 1/2. A is going down, so it's negative 9.81 meters per second squared, 0.4 seconds squared over 0.4 seconds. Now I always have people that then want to cancel out the time, but you can't because it's not in the first term. Okay, so when you punch this in the calculator, sorry, just trying to get the answer while I was talking, you should get a positive 6.962 meters per second. Okay, I think that's right. This then becomes the VI